We have a cone-shaped paper cup that's holding 10 centimeters cubed of water. If it's holding 10 centimeters cubed of water, that's the volume. So we'd have 10 equals 1/3 pi r squared h, or equivalently 30 equals pi r squared h, or h equals 30 over pi r squared. Now, we want to find the height and the radius of the cup that will require the least amount of paper. The least amount of paper means that we need a minimum surface area. So we took the surface area for a cone and removed the area for the top, the base of the cone, which would be the top of our drinking cup, which is just the circle pi r squared. That left us with pi r times the square root of r squared plus h squared as our surface area formula for the remaining portion of the cone. To minimize that, we need to take its derivative, but it has both an r and an h in it. So I solved here for h. I'm going to plug that into the surface area equation, and I get a is equal to pi r times the square root of r squared plus 30 over pi r squared squared, or pi r squared, whoops, no, that r is not squared, pi r times r squared plus 900 over pi squared r to the fourth to the 1/2 power. Now to differentiate that, we're going to have to use a product rule. So taking the derivative of the pi r squared leaves a pi, leave the other alone, plus leave the pi r alone, differentiate the other, we're going to bring down the half, rewrite it to the negative 1/2 power times by the derivative of the inside using a chain rule will give me 2r, and then minus 3600 over pi squared r to the fifth by rewriting that r as r to the negative 4, and then just bringing down the negative 4 times the 900. All right, now this is jumping on me. Let's go back up. All right, this is pi times that square root, r squared plus 900 over pi squared r to the fourth, plus, now over here we have pi r times 1/2 times this. I can just get rid of the 2 there. So get rid of the 2 in front of the r and cut the 3600 to 1800. I'm just taking half of everything in the parentheses. And then this negative exponent puts that square root in the denominator. So now, since I have a fraction on the right-hand side here, and this is a fraction over 1, I can get a common denominator by multiplying the top and bottom of this first fraction by that same square root. Multiply the square root times the square root, and the square root goes away, and you're left with r squared plus 900 over pi squared r to the fourth, divided by that square root, and then plus, I'll go ahead and distribute the pi r in here, so pi r squared minus 1800 over 1 pi will cancel, so that'll be pi, and 1 r will cancel, so that'll be r to the fourth, divided by that square root. Now, because they're both over the same square root, I can just make that 1 square root in the denominator. And so I'm looking for where it's equal to 0 of pi r squared plus, again, distributing the pi, 1 pi cancels and I have pi r to the fourth, plus pi r squared minus 1800 over pi r to the fourth, all divided by the square root of r squared plus 900 over pi squared r to the fourth. Now, since I'm trying to look for the critical values where it's 0 or undefined, first of all, I see this r in the denominator, so I'm going to say r cannot be 0. That's one of my critical values. But then the only place that it's going to equal 0 is where the numerator equals 0, because that denominator, all of that's being added together, it's positive. It's never going to be equal to 0, right? So adding together the like terms in the numerator, we have 2 pi r squared, and then plus and minus of the same thing, so 900 over pi r to the fourth. So this is going to generate my only critical value. So now adding the 900 over pi r to the fourth to the other side, and then multiplying pi r to the fourth to both sides would give me 900 equals 2 pi squared r to the 6, dividing, and we get 450 over pi squared is r to the 6, or r is the 6th root of 450 over pi squared. Now we just need to show that's a minimum. So we're going to draw our number line, plot that value, the 6th root of 450 over pi squared. And I'm going to pick something that is less than that, like say 1, and plug that in for the r. And when I do, I'm going to see that this derivative is negative. Then pick something bigger like that. 10,000 will work. It doesn't matter. Plug it into this derivative as the r, and we'll see that it's positive. That change from minus to plus tells me it's a minimum. So now we know the value that's the minimum for the surface area. To get the height, we go back up here and plug into this expression to get the h that goes with it.